Okay, but before we understand collector, we should have also understood the reduce method. Okay, yes, there are different things, but I'll show you what the difference is. Okay, where the difference comes. Fine. So, any other questions on the collector thing? Yeah? Sorry, on the reduce. Fine. See, reduce is understood, right? Yesterday we understood reduce here. Okay, fine. So, reduce was, yes, it was taking an identity, starts with an identity, right? Okay. In this case, what we are doing is we have a in reduce what we have is we have a starting identity. Okay, start with an identity and okay, so here's your identity, right? You start with an identity and process your elements, uh, apply the binary operator with the element, or it would have been a by function if the result type is not same as the type of the elements. Okay, you would be having a by function. Apply the by function. The by function is producing a new value. Then it's producing a new object. Okay, and this object is then used with the same binary operator again, but with the second element. The new generated object. Okay, this is a new object which has been generated, right? This is identity, but this is your I'll say this is your initial result, right? Identity is your initial assumed result. If there's nothing, this is the result. If zero elements are there, that's my result. Identity becomes my result. Okay, but if there is an element, I get a new object here, right? Okay, you are not going to use that identity again. Okay, now talking of the collect method. Yes, what's the collect method? I'll first write the signature again. Okay, let's look at that method signature again for the collect method. What are the things going as input in the collect method? Okay. Okay, so what's a collect method, right? So collect method is written as something like this. It will return a result of type R. Okay, so we have a type parameter R. Return type is R. Name of the method is collect. Parameter, the first parameter is a supplier of the type R. You can see it's a supplier of the type R. Okay, this is known as the supplier. Okay, I'll keep parameters in a separate line. Okay, second parameter is the by consumer of R comma T. Okay, this is your accumulator. Third parameter is the by consumer of R comma R, and this is your combiner. Result type is R. Partial results are going to be in R, and then you have a by consumer. Okay, and so this is the method signature for the first form of collect method, and the second form of collect method is having a comma r, two type parameters. Result type is R. Okay, the collect method takes as parameter a collector of T comma A comma R. Okay, so that's going to be the collector. Fine. First, okay, let's try to understand the concept of the first form of collect method, this one. Okay, fine. So let me explain here, because it has to be, you find similar thing. Oh, accumulator, combiner, the same concept. Right? Accumulator, combiner, the concept are similar to what was there in the case of reduce method. You can partition your input. Fine. It's going to be partition, and concurrent computation can go on. Okay. The accumulator is going to be used multiple times with each and every element. Fine. So if it is partition, yes, every element in the partition is going to be used again. Right. Now, the difference from the way reduce method is used here, one thing, we are talking about the result type R in the first form of the collect method. The main difference here is in reduce method, the type of result is R. Okay. What about the R, whether it is, does it matter whether it is mutable or immutable? I'm talking about now mutability of the type R. Here, identity is of type U. Yeah, is U mutable or immutable? Does it make a difference? It doesn't make a difference, because after applying a function, a bifunction, you get a new object and you use the newly generated object. In case of collect method, okay, fine, this thing, what you get through a supplier is this basically, and you are not having a function. The difference here is, okay, look at that. What's the input? A supplier of R, right? That's the first. Second, accumulator. What is the accumulator? It's not a function, not giving out. It's a consumer that's not returning a value. If it's not returning a value, there's no question of looking at something new. You're not going to get something new out of it. Okay, so the difference comes here. Okay. Okay. So first is you have an object of a supplier here. Okay. Fine. What the supplier has to give has to be a mutable type. That's the first thing here. It cannot be immutable. What the supplier is going to give me is some object. The object is of type R. Okay. So here is some object. Okay. For example, this object would be a type which is normally going to be some kind of a data structure. So if I'm saying supplier, it would be a supplier of list, a supplier of set, or some such thing. The result type is going to be a set or a list. Okay, they are going to be mutable. Fine. Okay. So I have got one object. This is my object. Let's say this is R1, because this is for one partition. This is for one partition. I'm assuming for one partition. So I've used the supplier. So here's the supplier. Okay. So there's one supplier. Fetch the first R1 from it. Okay. And then we have P1 coming from the stream. Okay. Both of these are given into a consumer. Okay. And that's it. Fine. What is the next? For the next element from the stream, I use the same consumer. I use the same R1, but it's only that I'm fetching a new P2. This object, which is generated by the supplier, is a mutable type. It has to be updated by applying the, by using the first element from the stream, it has to be the same object which is getting updated by using the second element from the stream. It has to be the same object. So this is the one which keeps on getting updated. It has the updates coming from the elements of the stream. See, for example, it is a set. I keep on adding the elements into the set. I'm collecting them into a set. Okay, so this is one thing, right? So this has to be definitely a mutable type, something which will be updated, which can be updated, which on which a change can be carried out. If it is not a mutable type, then no, collect is not going to work. Okay, so maybe you are generating a set, supplier of a set, fine, collect all the elements into the set. So this will be in one partition, another partition, fine. So you will have multiple such sets. The supplier is always giving me an empty set. So for any partition, right, if I partition the input into, fine, it has been broken into various partitions. So for each partition, a separate set would be used for collecting it. Right? And then once I have those sets which have been used for collecting, so this is my, okay, so what I should be doing is here it's the same thing used again. Let me just show it as if it's used again. Okay, this is the first input, second input is T2 here. Okay, fine. So it's updating the same object. Okay, so update this object for T2, update this object. So two things, right? Going into the, fine, there is T3. Okay, both given as input to the consumer. Consumer doesn't produce a result. But within the consumer, what is assumed? The first parameter in the consumer, it's a by consumer basically. The first parameter in that by consumer is a mutable type and is going to be updated, and it is going to be used again. The same object is going to be used again with the next element coming from the stream. So by consumer called multiple times. Okay, so for example, fine, now I can write a code. Fine. So with this, let me just put a simple code, fine, where we are able to collect all the elements into a set. Okay, we won't have to use this for taking all the elements into a set, but just for the understanding sake, fine, how those three parameters may have been.
Last, the combiner will combine all these consumers.
Okay, so yeah, how the combiner works here. So we have R1, right? Like we have R1, we will be having another place, we will have R2 also. The R2 was derived again from the same supplier. R2 is my initial object. Okay, it's like the identity which was used there, right? But this R2 is, so this one, the supplier, fine, in case of a set, if I'm assuming it's a set we are taking, it's always giving me a empty set. Okay, it's giving me empty set. So yes, so like we have R1 and R2, right, R3. Okay, so the other by consumer which we are having is a by consumer of R comma R. So that's is used for how do I combine two of these. So sorry, so both of these will be given as input into a by consumer. This is the second by consumer. This is the other one. And two by consumers were there. One was R comma T, other was R comma R. And so this one, right, these are, it's the same object. I have just shown it repeatedly because it's going to be applied with multiple. But this is my first by consumer. This is the second by consumer. Okay, so let's say how we collect all the elements into a set. Anyway, it's much, there are much easier ways to do it, but we'll use the collect method to do it. Okay. Then we'll use the collect method to do this, and for that let's see this. So we are first using the first form of collect method. Okay. Okay, so I have a stream of string, let's say. Okay, let me assume stream of string. We had done that distinct words. Okay, so stream for the distinct words, right? So whatever it may, okay, let's say I'll call it as the word stream. Okay, let's not worry about this. Okay, but on the word stream, I now say, let me have a set of string. Okay, is equal to word stream dot collect. Fine, I'm directly using the collect method. What's the first parameter I have to give? I have to give a supplier. Supplier means no input, only return an object. Fine. So here it's going to be a supplier of, what's the result type? The result type is the set of string. This is my result type. R is this. Okay. So it's a supplier of set. So how do I supply a set? No, not set. Set is interface name. So we'll have to say hash set. I want to use the hash set. First parameter is a new hash set. Okay. Fine. No input. Fine. Call the default constructor of hash set. So an empty set is returned by the supplier. Each time someone says get, yes, you will get a empty set. So this will be getting created for each partition. If it has done partitioning, this is what is going to be created for each partition. Then the accumulator comes into picture. Let's see the accumulator. So what's the accumulator going to be? The type is set, right? Set of string. Okay. Accumulator has two parameters. Okay, I would, okay, I'll write it in two forms here. First, I'll write it in the form of a lambda. Okay, so given a word set, okay, so we will have two inputs, right? Set and element. Okay, and then we'll say set dot add. This is the lambda. Fine. Okay, comma, and then the third parameter will be there. But instead of this, a better way would have been to use a method reference. Just say add. Will it work? No, this won't work. Yes, we'll have to write a lambda only. Because that add method actually returns a value. It's not return type void. We need a return type void. Okay, we need a return type void. Okay, what's the next one? Once we have all of these set, and there will be multiple set object, one for each partition. So we are saying given two set S1 comma S2. Okay, what we should do? S1 dot add all S2. Merge it. And you get the final set. So what you have given is what kind of data structure you are going to use. I said it has to be mutable, so it's going to be some data structure. I want to use the hash set object, right, for collecting the elements. Okay, how do you collect? By using the add method. Okay, if you have collected and if the two sets have to be merged, how do I combine two sets? It's a by consumer which is needed there, right? Okay, and so this is the first form of collect method, okay, which we will not be using most of the time. Okay, we may not use it, right? It's a second form which is the collector. So yeah, it says collector. Yeah, we have a collector of TAR. So what is a collector? We passed 3 parameters in this, right? Or this one says there are 3 parameters in this. Okay, just think, instead of writing a thing like this, okay, I'm going to write a different form of a collect method, which is not existing, but I'm just writing it for your understand, for the sake of understanding. Okay, I'm going to rewrite this and say, no, I don't have a collector, but instead I have some object which uses a supplier of A. Okay, so that's going to be the supplier. It's also going to use okay, other than a supplier, it's also going to use an accumulator. I need an accumulator. Accumulator is going to be of type by consumer of A comma T. Okay, so that's my accumulator. Okay, there's also going to be, now it's not a by consumer, but it's a binary operator which is used here for the type A. So this is a by consumer for A, and this we call as the combiner. There the combiner was a by consumer, but here it's a binary operator. What is used in the, and the fourth parameter is going to be a function from A to R. Okay, this is my finisher. We call it as a finisher. Okay, and this other collect method is equivalent of doing this. It's nothing but, what is a collector? Collector is just an object which has these 4 things in one place. And collector is composed of 4 components. Okay. These 4 components are nothing but your functional interfaces. Yeah, all the 4 types. Supplier is a functional interface, by consumer is another functional interface, binary operator is another functional interface, function is a functional interface. So it is made up of 4 things, 4 components. And those 4 components, first one is a supplier, second one is accumulator, third one is a combiner, fourth one is a finisher. Let's look at the role of each of them now. Okay, how each one is used. So look at a collector, right? Here is a collector object. What does it have? It has one object which is a supplier. Okay, it has a supplier of, what are these TAR? What are the three things TAR? T, the type of elements to be processed. Multiple elements will be coming. So T is the type of elements coming from the stream. Elements, multiple elements. Right? What is the A? We call it as the accumulator type. A is my accumulator type, which has to be mutable. And what is R? R is my result type. When R is going to be my result type. So this is going to give me a accumulator type. The first one is a supplier, which is going to give me a accumulator type. What's the second one? The accumulator. Okay, which is going to be by consumer. Fine. First one is a supplier, second one is the type is by consumer of A comma. A is my accumulator type, which is mutable, which has to be updated with the elements from the stream. So I have these two functions. I have a third function which is used for combining. So this is the third object is the combiner. Okay, the type is binary operator of A. Binary operator of A. And A is generated for each partition. An object of type A will be generated for each partition. We assume that input is going to be partition. Okay, so I have got multiple A's. Okay, when the combiner would not be used without going through the accumulation process. Only after the accumulation process is over, then the combiners will be getting used. Okay, fine. So this will combine and give me one A, final A, where all the things have been combined. And then whatever the final A is, from that, final A is a mutable type, but it's not a good idea to return something which is mutable. So you put a finisher. You put a finisher. Pick this up, and from this, what you would like to generate is so finisher is going to be a function. Okay. Function whose input is A. You have finally accumulated everything into one A. Use that and generate a result. You decide how you would like to return, what you would like to return from there. You have collected into a hash set. You may like to return an unmodifiable set or convert to whatever. You decide. You have got everything in one set in some data structure which is good for you. Okay, you decided to put it in some kind of a structure. Fine. From that, everything whatever you wanted, you have collected and then convert it into a final result which you would like the collect method to return. It's not the collector which is returning, it's a collect method which is returning. Collect is only having, I have these 4 functions with me. Fine. And if you pass it to the collect method will use them. So it's, collector, one single object to accommodate the 4 functions. Fine. Collector is nothing but one single object where all the 4 are available. Okay. How do we create a collector? Okay, one more point here. This collector has got characteristics. They have said, okay, collector can have characteristics. The entire collector is said to be having characteristic. Yes, the characteristics are used so that it knows how to optimally use the four things. Okay, so a collector may be said to be concurrent, or whether it is concurrent or not. So we have a collector characteristic called concurrent. Fine. Collector can be said to be unordered. So internally maybe the mutable type may be a list type or a set type, ordered or unordered, and what type of collector it is. Okay, and a third thing about a collector, it says, okay, the collector is an identity. So when it says identity, okay, what it actually means is I don't want to use the finisher. Whatever is the result generated, that's it. There's no finisher applied to be applied here. Okay, or the finisher is the identity function. It basically means the finisher is simply the identity function. What is the identity function? Whatever input you give, same becomes output. And that's an identity function. If you recollect, the function interface called function has a static method called identity, which returns a function. Okay, and that function is nothing but whatever is the input, same becomes output. Does not do anything. Okay, so there are three characteristics available. This I have written in capital letters. Yes, we have this as a enum. There is a enum called characteristics. So we have a enum collector dot characteristics. Okay, where those three are the enum objects. Yeah. So collector dot characteristics dot concurrent dot unordered dot identity. Those are the three options. Okay, three enum objects. This is a enum type. Characteristics is a enum type. Okay, fine. So how do we create a collector? And various ways of creating a collector. So one of the options to be used here is, let's see, four components. Yeah, what are the four components? Supply, okay, fine. The types are listed there. We don't have a collect method like this. Okay, this is not a collect method, but instead of saying collect, okay, instead of this, basically, instead of all of this, basically it is, okay, it's a, instead of all this, I should have written simply fine. So that's not a method. Okay, this one is not a method. This just to show that the collector has all those four things in there. And this is what the collector is made up of, is all those four things. Right? Okay, I should say, this you understand is not actually a method, so don't get confused that this is some method like this. There's no method like this. The method is this one. But then I'll need to create a collector. Let's see how to create a collector. Okay, so one of the ways to create a collector would be to use the static method in the collector. So if you look at collector of T, comma A, comma R, okay, there are static methods to create the collector. Okay, so we have the public static method. Okay, type parameters are T, comma A, comma R. And these are the type parameters, and it returns a collector of T, comma A, comma R. Okay, so the method is returning a collector. Name of the method is off. What are the parameters? How do you create a collector? The parameters are a supplier. First parameter is a supplier of A. What's the second parameter? Yeah, so that's a buy consumer of A, comma T. Okay, yes, that's an accumulator. Next one, type is binary operator of A, comma A. This is the combiner. Next one is a function from A to R, which we call as the finisher. And there's one more parameter. It says dot 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 multiple. Okay, so that's the characteristics. Right? When it says dot dot dot, even if you don't pass anything, that's also 0 elements is also fine. Okay, so this is one method of. There's another one, okay, where we don't have the type A. Okay, so it's a collector of TRR. Okay, of supplier of R. The accumulator is from R to T. It's a binary operator for result type, because my result type is this, and there's no finisher. No finisher needed without using a finisher. Finisher was to convert it, that mutable type, into the whatever you like, right? So this is fine. This is the identity function. So two methods like this of methods. So that's the way to create a collector. Of course, there are many other options available to create a collector. Okay. There is a class called collectors, and that contains lot of static methods to create a collector quite easily, and for the different kind of common scenarios where we need it. Okay, fine, we'll see. But internally, a collector has those things. Okay, a few more things. This is how to create collector. The collector of T, comma A, comma R. Okay, methods are instance. Those were static methods. Instance methods. If I have to look at the instance methods, what does a collector have? So you can ask for them. You know, like a getter method. Yeah. Okay, so we have a public method to return a supplier of A. Name of the method is supplier. Just say I have a collector, I'll just say supplier on that. I'll get the supplier function. See those four components. So it's like getting those four components. Same way, you can now guess what it is. Yeah. What are the other methods? Public method returning accumulator. What is accumulator? By consumer of A comma T. Okay. That's a method name. Fine. Same way, another public method to return the by consumer, not by consumer, binary operator of A, and that's your combiner. So method name is combiner. Same way, we have a method called finisher, and that should return a function from A to R. So you can ask for individual components. Okay. Also, there is a method to return the characteristic array. Okay. Fine. Method name is characteristics. And so these things are available as instance methods on a collector. And so collector has four components, important part. Okay. And they have a role, how they would work. And first, uses the supplier to create one object of type A. This happens for each partition. Right? Uses the by consumer, calling that, passing that same object each time, object of the type A, but using all the elements in the partition as the second parameter. Okay, fine. After this is over, fine, this has to be over for each and every partition. Once it has finished for each and every partition, then it will combine the A, objects of type A. Fine. Whatever it gets by combining them is then subsequently used with the finisher to get the result. Okay. Methods of collectors. I have to give some sample methods at least so you get interested into it. Okay. Fine. How simple it would be to do certain things. Okay. Fine. I want to use this to find the average balances. I'm interested in averaging, right? So see, average is of type double. Okay. Right. But I will find average for, you do averaging for int, long, or a double type only, right? So it says fine. I can give you a collector which can do this averaging for you. You have a stream of some type T, let's say. So if for a stream of type T, okay, the collectors has a public and a static method, okay, which returns a collector of type, yeah, T is going to be some type T. Okay, accumulator type doesn't matter to me. How does it matter? What is used internally? I'm interested in knowing what it returns and what kind of elements it's going to process. It's going to process some element of type T and it's going to be generating a value of type double. The result is going to be of type double. Okay, because it's an average, right? And I have this method called, depending on whether the from whether the things to be, you do averaging on int or a long or a double. So I'll say averaging int. And what's the parameter to averaging int? That's it. You just need one function, toInt function for, so this is my mapper. I'll just say mapper, okay? And just equivalent thing for long and double. This remains the same. The method name is averaging long, and the parameter is the toLong function of t, or you have got the toDouble function. Now I'll show you some code. Okay, so let's say we have a stream of account. Okay, SA. Yeah. If you have a stream of account and I am interested in knowing the average of all the balances. Okay, so long is equal to SA dot collect, collectors dot averaging long yeah, done. That's a code to get the balance, average of all the balances. Okay, I've just shown you one method. You are interested in balances, averages, finding average. Oh, we have, just like we say averaging, we can say summing. Fine.
So it are inbuilt methods.
That's a method in the collectors. This is the class we have to look at what are all full of all kind of static methods, so that you can get a collector. And you can get a collector. For that, what do we need? A simple function, right? Which works on t to a primitive type in this case. And here we have used, because the balance is a long type. Okay, I want the average of balances. Fine. Just tell me how to convert your one element into a long, and I'll take care of averaging and giving. So I produce a collector, right? See, it's the collect method which has to be used to get the result. Fine. Here, collector is a parameter to the collect method. Just creating collector won't do anything. Creating collector, just I have built the thing, but call it, pass it to the collect method, then the things will work. Okay. Fine. The collect method is needed here. Okay, so just think like this. Just like we can have this. Okay, these three set of methods. I'll show you the other two equivalent sets here. Okay, this is a collector which returns double because it was averaging. Now instead of double, what it will be returning? Because it's averaging, not averaging, it is. Okay, yeah, in case of sum, we always get a long type, even if it's an integer. So we'll say averaging, not averaging, it is summing, and that remains the same, right? This becomes, here it will be long. This will be saying averaging, not averaging, it is going to be summing double. And the third one is more interesting. Int summary statistics. Method name is averaging int. Okay, and parameter is this. Not average, sorry, method name is summarizing. So you just say summarizing, you get the summary statistics. In summary statistics, long summary statistics, double summary statistics. Yeah, but you need to pass the collector object from this to the collect method. It just creates a collector for you. These methods are there to create a collector, which will have to be used with the collect method. Okay. And so this will be the long summary statistics. Averaging, not averaging, it is summarizing. Yeah. Okay. Yes, so I've just shown you a small sample of the kind of methods which we have in the collectors. So collectors give us a collector. Collector is required in the collect method for it to work. Okay. And so tomorrow I think we'll continue and we'll look at the static methods of the collectors class now. And before that, yes, anything else? And you should be clear with the all other methods of the stream. Right? Stream methods. See, it's a new way of working now. Okay. And a lot of things done by the API methods. The kind of parameters you are passing are the functions basically. They are just function taking some input output. Right? You're giving it, so functions are becoming parameters to my methods. When I'm saying function, I mean the object of a function interface here. Right? A lambda expression is a function. Okay? So we are passing those functions as parameters. Okay. And we'll see there's so many and very useful methods in the collectors class. So much of task can be done very easily now. You can see just one line of code, right? To get balance. Find average across balances. See, it's not only balance, it's any other field on which you would like to do certain things. Okay.
Implemented in account class.
We'll do it in account and bank. Test bank, that's a place where we're using it.
This all can be run in the main method only.
Yes, in the test bank main method, we'll run and test all of these things.
It will save us the time of creating so many classes and calling so many methods and calling them
Yeah,
separately.
yeah.
It is just one line.
Yeah, one line. Fine. Okay, fine. We continue tomorrow. Any questions? Yeah. Anyone else has questions?